Hi, everyone. Welcome to our talk, Why Spring Belongs in Your Data Stream from Edge to Multi-Cloud. I'm David Karamgar, developer advocate at Stream Native, and I'll be co-presenting with my associate, Tim Span, who's also developer advocate at Stream Native. So a little bit about myself. I'm a committer on the Apache Pulsar project, and I'm also the author of Pulsar in Action. I formerly worked as a software engineer on Splunk's internal messaging platform, where we ran Pulsar as an internal service, pushing 10 petabytes of data a day through the system. I formerly worked at a number of companies here as a director of solution architecture, solutions engineering, software engineering throughout my career. And as I mentioned before, I'm also the author of Pulsar in Action. We offer this book available for free download, complimentary. The entire book, all 401 pages of it, are available for download. If you scan this QWERTY code, follow the link, give us a little bit of information. You get the entire copy for your perusal after this talk. If you want to learn more about Apache Pulsar, I can highly recommend that resource as well. So let's begin. What are we going to talk about today? I will cover the introduction to Apache Pulsar and then hand it over to Tim, who will walk us through the development of an application using Apache Pulsar and the Spring integration that's currently been added to the system. He'll do a demo of that and follow up with some additional resources, GitHub repo, all that good stuff. You want to follow up and play with it yourself. That'll all be made available to you after this talk. So why Apache Pulsar? Pulsar has a lot of different features that come for free in the open source system, and compared that to other messaging systems out there like Kafka, who don't support things like multi-tenancy, easily elastic scalability, avoids that stop the world problem if you had to add an additional partition or add another broker and balance out the load very quickly. Comes built-in geo-replication out of the box. That was the initial use case at Yahoo when it was developed, to do a full mesh replication from eight data centers asynchronously, so the data is always in sync. There's not a secondary process around that does that for you, something like a mirror maker, some other replication backlog background process. It's all built into the system up front. It supports a unified messaging model, meaning it supports both streaming and messaging use cases. Other messaging systems do one or the other. Pulsar is the only one that actually does both. So if you want to get away from running two different messaging systems in your platform and only have one instead, Pulsar is a great way to do that. Guaranteed data durability, no data loss built into the system, and a lightweight stream processing function built in as well, called Pulsar Functions. So just making sure that all this is available in the open source feature is our philosophy. We don't give you a pared down feature set. It's a completely functional out of the box for open source, reducing your dependency on vendors and letting you get full value from the open source project from that perspective. So a quick timeline of where Apache Pulsar has come and where it's going. It started in 2012. Again, as I mentioned before, developed inside Yahoo internally as a cloud messaging service. It was the backbone of Yahoo Finance, getting real-time stock quotes from different data centers and different exchanges across the globe in real time. It was open sourced in 2016 under the Apache Pulsar licensing. And I initially joined the project around this time. We worked on getting it to be a top-level project, which is a significant amount of work. And then since 2018, when that occurred, we've achieved just phenomenal growth. 10 times the number of contributors, millions of downloads. We've expanded the ecosystem and added support for different protocols as well. We support Pulsar, the Kafka protocol, AMQP, Pulsar functions, tiered storage. A lot of features have been added since then, and we continue to grow. The ecosystem continues to grow. So doing a side-by-side comparison of, again, the two open source projects, this would be an apples to apples comparison between the two. So we obviously support time-based message retention. Both systems do that. That's pretty standard. Message replay is a common use case, that they both support. That's the storage system. You store the messages. You can go back and replay them as many times as you want. Run them through your processing engine to do recalculate events, things like that as you see fit. Where we start differentiating is where we have acknowledge-based message retention. Pulsar has the ability to guarantee that you can acknowledge the consumption of messages from each consumer. And you can have, some can be acknowledged, some cannot be acknowledged. We can have basically holes in the cursor and have messages redelivered automatically. That's not supported with Kafka. It has a single cursor per consumer because it assumes you're consuming the messages exclusively. And again, that's the streaming versus the messaging consumption pattern. We have built-in tiered storage. Again, this is the open source project. Other vendors add that as you have to pay extra for that. We have a built-in processing capabilities called Pulsar Functions, which I'll talk about. Very simple programming interface, allows you to process data in real time as it streams in. Kafka has a similar thing called K-streams to do that. We have queuing semantics, and which again allows you to have a work queue, throw all this data in here in one work queue, have hundreds of consumers come in and just grab at it as quickly as they can, process it very quickly. That's supported. We have also queuing semantics on key-based distribution, so you can support total ordering on a per key basis while still having multiple consumers consume that data. So again, you can have the best of both worlds. We have things like a dead letter queue as well. We have scheduled messaging and delayed delivery, rebalance free scaling, elastic scalability. We support 10 times the number of topics that Kafka does. So if you really have to fan out your data and structure your data in such a way, you have a lot of topics. Pulsar supports that easily. Multi-tenancy out of the box, as I mentioned before, so you don't have to have different clusters for each individual organization within your unit, than your organization. You can have, every department can use the same shared global Pulsar cluster, and you can partition it off in such a way that each tenant is isolated from the other one. Each one can get their share of resources and still acted as a single system. Built-in geo-replication out of the box. Again, you can do full tiered, full mesh replication natively. Schema management, our schema registries built in natively to the system, and we support end-to-end message encryption. That means a producer can, using a public-private key pair, take the public key and encrypt the messages, and it remains encrypted the entire time, and only the consumer with the associated private key can consume that data, making it much more secure way of storing that data, much more secure end-to-end processing. So again, it's a unified messaging platform, guaranteed message delivery. We don't lose any messages whatsoever. We can scale our storage infinitely. We're built to be cloud native resiliency. So again, the broker and the storage and the serving layer are completely separate. So if one individual broker or set of brokers dies, you don't lose the associated data that's stored with it, that it's all just takes over automatically and can immediately spin back up as well. And that feeds to the infinite scalability as well. If you need more brokers, you can just scale them up. If you need more storage capacity, you can just scale in nodes there and increase your scalability, and it can happen transparently. It's done automatically using our stream native operators can do that for you automatically, or you can set that up yourself to function as well. So getting into the guts of Pulsar, what is Pulsar at a high level? We break it down into three key components. So the brokers, as I mentioned before, is the endpoint that all your clients and producers interact with. It handles the consumption and publishing of the messages from that, and they're stateless. They don't store data on that. That's kept in a separate tier called Apache Bookkeepers, as shown here. This allows us to distribute the load dynamically across these brokers, right? If one broker becomes overweight or heavily utilized, we can offload some of those topics and say, hey, broker number 2, go ahead and take over some of this load for me. You're now going to handle this topic. And we're only able to do that because, again, they're stateless. All the storage is kept at a separate layer, so it makes it very easy to do that. If one goes down, again, you don't lose the serving of that topic. Another one can take over for it very easily. The storage layer is handled by Apache Bookkeeper, which consists of a series of stateful, what we call bookies, that store the messages in a segment-based model rather than a append-only or write-ahead log sort of model. So this allows you to distribute the data from one single topic across multiple bookies and periodically roll those segments and start and pick a new set of bookies to share that load. This makes sure that the data is very evenly distributed across all these different components. So when you want to read the data from the topic at different points in time from different clients, you can fan out those reads across these different brokers to get better throughput performance in that regard. And again, it's infinitely scalable. If you add just a new bookie to the resource pool, all that storage capacity becomes immediately available for consumption. And then what ties these two together so that you know what segments in the bookkeeper layer map back to topics in Pulsar, that's what's handled, what's called our metadata storage. It's pluggable, so we support different technologies for that based on what your use case is. Originally, we used Zookeeper for that metadata storage, and that's still an option today. But for those of you that are running natively in the cloud, you might want to start instead using the etcd key value store that comes natively with a lot of Kubernetes deployments. It simplifies your deployment. You can have a zookeeper-less deployment model. It's one less component to maintain, and you still leverage the existing Kubernetes infrastructure in that regard. We also support RocksDB and in-memory things for things like unit tests for standalone. If you want to spin up quickly and test a cluster on your desktop, you don't need these additional resources of a zookeeper or etcd around. You can just run it in memory, so it makes it much easier to stand up and play with Pulsar in standalone mode on your own desktop. Logically, how we break down the component or break down the namespace within a Pulsar cluster is we start with tenants as a top level concern, right? So every tenant can represent a different organization or different unit within an organization. So in this case, we have data services. You could have a marketing team. You could have compliance team. You could have finance team. They could all have their own tenant. And then within these tenants, we have what's called namespaces. And namespaces are logical groupings of topics that have similar policies, right? So if you want to set longer term retention policies or security policies, access policies on a whole bunch of topics at once, you put them in the same namespace and then set a policy at that namespace level. This allows you to easily manage policies when you have millions of topics. Remember, we support millions of topics. You don't want to have to manually change those settings for all 1 million topics. You want a way to shortcut that, and namespaces is the way to do that. And then at the very bottom are obviously topics last. So every individual topic is just a name channel. Everybody, and you can set policies on topics. You can set policies on namespaces. You can set policies at the tenant level. So you have full granular control over who can access what, how long the data is retained, whether it has to be encrypted or not, whether it's offloaded to tiered storage. Lots of different options with this. And this allows you a mechanism for controlling it and manage it very easily. At the very inside those topics, at the very bottom are our messages, and our messages contain more than just the payload, right? So as you can see at the top, obviously that's the most important critical component is the value, the data payload, what it is. Everything is stored as raw bytes, and then we overlay a schema on top natively. So from a producer and consumer, you connect, you specify what schema you expect those bytes to be in, and Pulsar handles the serialization of those bytes back into the representative type, which is very nice. It makes sure also we have schema enforcement so that you can't publish garbage in there. The bytes have to conform in some way. But in addition to this raw bytes, we have some metadata that you can leverage to do some additional features, which is really cool. Things like key is one of those values. You can attach a key to a particular message, and then you can take advantage of our key shared subscription type. You can sort by key. You can do compacted topics, which will keep only the most recent value for a key, for example. So lots of different options with the key. We also support an unlimited bucket of key value user-defined properties if you want to attach some different additional values that are out without having to change the schema of your payload, but you want to consistently pass these values around, like where the data originated from, or a timestamp or something like that, that you can look at and access these properties. It's a very convenient way of doing that. Last but not least, we have a producer name. We tag who sent the message. So we know its origin. We track it, so you can track the lineage of this data throughout the process. And associated with that is a sequence ID. So each producer tags it with a sequence ID, and this allows us to make sure we don't process the same message twice, right? So if for whatever reason a producer disconnects and we have the messages resent because we're not sure what happened to those messages in flight, we can safely resend all those messages and using the producer name and sequence say, okay, these are duplicates, and we can effectively drop those. So it's a nice mechanism in there to make sure that, again, back to maintaining that data guarantee that we talked about. No data is lost. Once a producer sends it or resends it, we're never going to lose it. So at a high level, again, it's a producer-consumer mechanism. We talked about you have the broker. There's a topic sitting there served by an individual broker. A producer connects to the topic, says, hey, I want to publish on this particular topic. It's automatically routed to the proper broker who's serving it. And a consumer subscribes and says, hey, I want to subscribe to this topic. I want to start receiving messages from that, and it automatically is routed to the same broker as well. And they connect and they can exchange messages in an asynchronous manner, like any other messaging system. So it's a very simple, common pattern that you're very familiar with. Again, if messaging's been around for 30 years, we use these same metrics as well, but underneath the covers, it's slightly different. And here's how we differentiate ourselves, and talk about this slide a little bit in detail. On the left, we have a Pulsar topic, and we're showing all the different ways and protocols that you can use to talk to and publish data to a Pulsar topic and consume from it, right? Traditionally, all messaging systems up to this point have their own native protocol to send messages, right? Whether it's an AMQP with something like Rabbit, whether Kafka has their own Kafka wire protocol, Pulsar has its own protocol as well, MQTT. They all have their own messaging protocol, and they're all slightly different. They all have their messaging primitives for sending and receiving messages. Pulsar supports all of these. Now, we have what's called a pluggable protocol adapter that allows us to speak natively all these different languages or all these different messaging protocols. So what does that mean to you? Is that if you have an existing RabbitMQ application, or you have an existing Kafka application, or you have an existing MQTT application, in order to swap out from your existing messaging system into Pulsar is a zero work operation. You can just point the code, change it to point to the different URL where Pulsar is running, and it's seamless to you. The consumers and producers just pick up where they left off. You can write messages seamlessly. It's transparent. And now, because of these support for all of these, as shown by these little green leaves here, and Tim's going to demonstrate, you can use Spring plugin adapter to natively wire these things in, right, natively using whatever wired protocol you want, and consume the messages and produce the messages. On the consumption side, I want to talk a little bit about the different subscription types. So we see here we have 4 different subscription types available in Pulsar, and it controls how the messages are distributed across the consumers, who gets what messages, how they're delivered, and what the guaranteed processing order is. So starting, and then these can be broken down into which one you type to use, that defines whether you're using a streaming use case or supports a streaming use case, or whether you're using a more traditional pub sub messaging use case. So starting at the top is what we call the key shared subscription type. And what this guarantee is that every individual you can have as many consumers as you want on the same subscription. So you can scale up the number of consumers, infinitely to meet your needs. The guarantee is that all messages with the same key that we saw on the previous slide, as long as you attach a key to that particular message, they're guaranteed to be routed to the same consumer and in the order in which they were processed and received on the broker. So you can get in-order processing on a per key basis with infinite scale. So this is a really great use case for things where you have a lot of data coming in. Let's say IoT sensor data, something like that. As long as they have the same serial ID number for a key, you can route that in there, and then you compute your moving averages accurately because the data is processed in the right way. The next option is for those of you coming from the Kafka world to be most familiar with, is the failover. So you can have one active consumer per partition on the topic itself, and that each one of those consumers gets all of that data in the order exclusively on that particular partition, right? So it's going to, if you have 3 partitions, you can have at most 3 consumers. If you start up a 4th one, it sits idle and will only take over in the event that one of them fails, and it will pick up where the other one left off. So that sort of limits your scalability, but you are guaranteed to get all of the messages on that partition into that same consumer in the order they were processed. Third is the exclusive. So if you want to do true fan out, if you want to have multiple consumers, you can only have one consumer active on the subscription at a time. So you're guaranteed to get all the messages. You'll get them in the guarantee, or ordering guarantee is obviously maintained because you get them in the order that they were processed. And if anybody else tries to attach on that, they're going to be rejected. And this will give you another streaming use case. This is your full fan out use case. And then last but not least is what we call shared. And this is where you can have as many consumers as you want attached to a subscription, and they only get a subset of those messages. So this is more like your traditional work queue, right? Everybody comes in, consumer, the first consumer there is going to get a subset of those messages. He'll grab a message. The second one comes in, they get theirs, and so on and so forth. And when they're done and they acknowledge the message, they come back and they get the next one that's available. So they're going to get, each one's going to get a subset of the data, and you can process that data very quickly. So again, this supports your traditional messaging work case on that, right? So again, this is the verbiage for that. Producers send messages, topics are the channel which we talk to, the brokers handle the connections around the messages between the two. The messages are the smallest unit that contain the payload, they contain the metadata. We talked about the keys, the properties, the producer name, the sequence ID, and these subscriptions are maintained, and they're the configuration rules that determine how messages are delivered to one or more consumers, who can attach, who gets what messages at what point in time, and handles the routing of those messages from the topic to these different consumers based on those different rules and those subscription types that you define. It also maintains an internal cursor or offset. So when a consumer gets a message and says, okay, I processed it, it'll send an acknowledgement back that said, yes, I processed it, and update that cursor internally so you don't have to worry about that as well. And then the consumers just receive the messages and they can either acknowledge them or negatively acknowledge them. Again, this is what we talked about before with the different subscription types, showing you how the messages are routed. In a two producer, so you can have multiple producers right into the same topic as well. That's fine. You can have multiple consumers fanning out and consuming on these different various subscription modes that I talked about in the previous slide. So open source unified messaging, this is the greatest platform. It does everything, speaks all the protocols, does all the messaging, infinitely scalable. You know, take my money. This is the best solution. This is what you're looking for, unified platform on that. Additional features that we have is a built-in schema registry, right? So we mentioned before, open source out of the box, everything comes natively. Schema registry is built in out of the box. We support schema enforcement locally. So producers come in, if they attach later on and they have a different schema change, they can automatically update the schema and keep older versions of that, right? So schema version 1, schema version 2, schema version 3 can all exist, coexist, and based on compatibility rules, are they forward compatible, backwards compatible? They can coexist inside the same topic. And then the consumers can eventually update to process this on different versions of the schema as well. So you can maintain this information there internally, and it's all built in. You don't have to stand up a separate service. All this information is kept internally inside the Apache bookkeeper layer, and the schema registry is handled by the Pulsar brokers themselves. So you can always get this information, and the producers and consumers can access this information to make sure that they're publishing, again, using a compatible schema based on the enforcement rules as well. So this is a great messaging system, but how we have to, in order to do anything useful, you have to sort of interact with other systems, right? Today, solutions are developed using a combination of technologies. As great as Pulsar is, it's not the end all be all of everything. And so we have a very diverse ecosystem, starting with the protocol handlers that I mentioned before. So we speak these different messaging languages. So if you want to send data, receive data from IoT, for example, using the MQTT client, you can do that very easily and send it natively to Pulsar. You can consume from MQTT and publish it out to an AMQP client, for example. This is a very cool thing that's never been done before. Lots of different programming languages supported, everything from, Java, Python, Go, Node.js, Rust, Scala, everything, WebSockets, everything is there supported. We also have an IO framework. So we have different sources and sinks to get data into and out of Pulsar. You want to, process your data, do change data capture. We support Debezium, for example. You want to move data or process it into your Delta Lake or into Iceberg. We have that connector. It's very easy to plug it in, say, take the data from this topic with a few configuration rules and write it into any of these systems here shown below. We have the lightweight stream processing, which we'll talk about in a minute. You can write native functions inside Java, Python, or Go supported engines, processing engines. You want to do distributed processing, more complex things, joining of streams together. We support natively connectors for Flink and Spark and Presto, you name it. And then last but not least, tiered storage offload, right? If you want to not have your data all kept on your storage layer in Bookies, which is possible, you can scale it infinitely, but it's oftentimes more cost effective to offload it to something like blob storage somewhere, Amazon S3, Google Blob Storage, write that information there, and it's immediately available as well. That's the other cool factor. If you write it to tiered storage and then you have a consumer come back and say, hey, I want to read this message that's been offloaded, you don't have to rehydrate another node like you would in a messaging system, other messaging systems to first make it available on a node. It completely just reroute that request out to that tiered storage and read that information directly off of that tiered storage as well. So Tim loves, those of you who follow Tim a lot, he has the flipping stack, he invaded that. So it's Flink and Pulsar and NiFi all together. And he's going to show you in this demo some of these different. So we have MOP, which is MQTT on Pulsar, AMQP on Pulsar, Kafka on Pulsar, and WebSockets. All these different ways that Pulsar can speak these different protocols and send messages back and forth. And any of these kittens can talk to the other ones using a different protocol. They all can speak to one another, and Pulsar makes that possible. That becomes the central hub for all this communication protocols with that. So again, I talked about it a little bit, but this is how the protocol handlers plug in natively. They could just natively speak So Pulsar producer and consumer, again, can talk directly to our Pulsar protocol handler. And at the same time, you can have a Kafka protocol handler there inside that little blue box, and both simultaneously publishing to that same topic, which is really cool. So they can cross communicate with one another. You can have applications that using the Kafka client right into this topic, ones that are using the Pulsar client right to this topic, and they can receive messages from one another. And again, it's transparent. It's just another layer that allows you to plug in whatever protocol you want. Any future protocols that come in, they can just be plugged in as well. MQTT follows the same strategy, right? You can have an MQTT protocol handler as well, connecting directly to that topic, and a Pulsar connectors talking as well. Again, these are, and Spring can be configured to do your MQTT. So again, it becomes much easier with this talk, and Tim's going to show you this. AMQP, again, a similar model. So if you have things like RabbitMQ, or you want to use the RabbitMQ library, you can talk directly to Pulsar. Again, it's transparent. It's just a different port, and it's all listening as well. And then last but not least, you can, if you have data existing in Kafka, you want to get it over to Pulsar, we have Pulsar syncs. You can liberate that data out. Again, we can natively speak it, but if you have your existing data in there, you want to move it over to Pulsar, that's a simple IO connector. You can say, bring out the data from this Kafka topic, write it into this Pulsar topic. That's just a simple configuration rule. Boom, you're done. The data comes out. Similarly, you can bring it in, ingest data from all, Apache Hudi, your Delta Lake, your Iceberg, your long-term storage, anywhere in your lake house. Bring data into it. You can also write it back out. So it plays nicely with your lake house. And last but not least, you can start querying this information and all this different, information on that as well. And with that, I think I'm going to hand it over, or not yet. This is me, right? Is this me, Tim? We can edit this out.
Yeah. Just wrap these two up and then I'll pause it.
Okay. Yeah, I don't have the number on that. So yeah, last but not least, so take two from here. Last but not least is the Pulsar functions, which is again our serverless event streaming framework. So for those of you familiar with AWS Lambdas or Azure functions, this is a very similar model. You have a very simple API. You have a single method interface that you have to implement, but it's designed specifically to use Apache Pulsar as the message bus, right? So you just configure it up. Say I want to consume messages from this one or more topics. This is the code I want to execute on it, and I want to publish the output to another topic. And you can specify different runtimes for that, right? So you can do everything from a thread runtime running inside a Pulsar broker. If you want to run your Pulsar functions on the edge, you can do function workers. You can do Kubernetes pods. Lots of different options. Again, we support Java, Python, and Go with that, and it's a very simple programming model. So again, you say, okay, I configure it to say, hey, I'm going to consume from these various input topics. I'm optionally, if I want to generate any output, I can publish an output topic. I have a log output. If I want to optionally record any errors or things like that, I can do that as well. And these are great because you can execute any code you want, right? You can package them with third-party libraries. If you want to bring in machine learning model execution models and do complex machine learning on a per event basis, that's completely supported. All these different capabilities are there. And with that, I'll hand it over to Tim, who's going to show you off some of these cool features here as well.
Thanks, David. That was a great introduction to Pulsar and all the amazing things you could do with it. I'm Tim Spann. I'm a developer advocate at Stream Native. I cover what I call the flippin' stack, which is Flink, Pulsar, NiFi, working together with all the great tools out there like Spring and Java, all different big data cloud tools, IoT, machine learning, lots of different stuff. I used to work at Pivotal, where I got to work with some awesome Spring stuff, which is why I'm such a fan today. Now, when you're building these real-time apps, you saw the power of Pulsar, but you need a complete team to be able to build these real-time apps in the ways that you need to do that quickly, solve any problem that might come up. Each of these frameworks and tools have their own pluses and minuses and things that they excel at. And when you combine them together as one team, you can accomplish anything very quickly, scalably, and without too much difficulty. Well, one of those pieces of that team is Apache NiFi. It's an open source Java tool that has a great connector for Pulsar, lets you consume and send messages very easily, do this in a graphical manner. this is a great way to get your data started. So when I'm going to write code in Spring, I'm writing the most important code. I'm writing the business logic. I'm writing the important decision-making tools, the apps that do something, whether it's in the front, in the back, in the middle, it's client-facing. It is the code that needs to be written because you can't do it any other way. Cloudera and NiFi make sure that I could do the boring stuff, so I'm not wasting time trying to figure out how to read every type of file, open up every kind of connection just to stream that into Pulsar to distribute it to other people later. Let's NiFi do that, connect to any cluster with whatever security you prefer. Something like Stream Native Cloud has SSL plus OAuth, multiple levels of security there, plus encryption, all those things very easy to configure in NiFi. Just makes a simple way for you to get data into Pulsar so I could start using it in different applications. In the same manner, Flink has a great connector to get into Pulsar. This will let me consume what I need to from those topics. So say in this example I'm going to show you today, I have a Spring app that is reading some REST data on air quality and funneling that into Pulsar. And then I could have a Flink query running there, doing analytics on them real time. Pretty easy with SQL, but you could also write it in standard Java, Scala, or Python if you want to write more apps and not just continuous queries. There's a ton of tools out there in the cloud that lets you have a nice console, write your query, press a button, deploy it, real easy. Whether that's coming from Pulsar on premise or in any of the clouds, very easy to do. Very easy to join that with other sources of data, whether it's in Pulsar or somewhere else. You could be joining it with Kafka or some databases, makes it pretty powerful. And it could be stateful. So if you need to keep a running total, you don't have to worry about things going down. Need to scale out, you could just keep scaling, adding more nodes, query keep running, just gets faster, support more data. And we're talking millions of rows, petabytes, terabytes, lots of data, and doing it very easily with simple code, simple SQL. And I'll show you some examples of that. Here's a couple common queries that I'm doing on the air quality data. Maybe I just look at some of the fields. Maybe I'll do some maxes on different values, trying to find, when's the air quality the worst, the average. You could do all the queries that you expect to be able to do with SQL are available to run continuously in Flink. So you could do things like unions and joins and order by and group by. But what makes it different is as events come in, so Spring created a record, pushed it into Pulsar topic, boom, it's in my query. And I'll try to change the screens fast enough so you can see that. I don't know I'm fast enough to do it. Maybe I'll leave 2 windows running. Probably should do something like that. Makes it a little easier. But I like see my data as big as possible. We'll have to see what makes sense. So I'm going to show you a demo of the Super Friends here. Spring, Pulsar, and all their buddies. But let's look at a couple different optional architectures I've got. I've got a couple of different demos, and I'll make sure you get those GitHubs so you can start running your own code. So Spring Boot app, which is my favorite, easily pushes data to Pulsar. In Pulsar, I've got a function like David was talking about. It's doing a little NLP on that and pushing that into other topics. Again, or it could sync it somewhere. Got a lot of options. Usually I write these in Java, but I could do Python and Go as well. And then once something's in a topic, you can have as many people consume it as you like. So it could be a Flink app, a Spark app, a NiFi app. We could use one of Pulsar's syncs to stream that into Delta Lake or into Iceberg or Hootie or any of your lake houses. And you could have apps, and they could be apps from Python, Go, other languages, or even talk REST, get the data in and out, so I could have multiple topics of data, join them together to keep adding layers of analytics. So yeah, I've got real-time data coming off a Spring Boot app. I could join it with a Python data, whether that's sensors or whatever it may be. Pretty straightforward. This also gives you an easy way to take whatever data from as many Spring apps as you want, get that into some topics, and have that streamed into Delta Lake, stored in the cloud for you, or an Iceberg, wherever you might want to store your giant data as you get it outside of your apps. Pinot's another one. I like Pinot and Pulsar. Sounds good together. Sounds like something you might want to eat and drink sometime. But today's app itself that I'll do the full run through is this app here. We have a Spring Boot app that's reading from the Air Now US API for air quality. I'm going to push it into a Pulsar cluster. And in this part, I'm going to just show you the Pulsar route. Remember, we have these different protocols. I've got other code out there in GitHub that uses the Spring libraries to do it with Kafka, do with MQTT, AMQP, bunch of different protocols. And then we got a function that does a little cleanup, changes the schema, and also parses it into individual types of air quality, as there's different types of readings out there, PM 2.5, PM 10, and ozone. These are just things they track to see what the air quality is out there in the world. And then we'll do a little analytics with Flink, but we could also do them with Spark. Again, whatever library or language that you prefer is the way to go. So let's take a look. Let me make sure my cluster is still running. This is my open source administrative tool. I'm going to take a look at our different topics out there. And I've got ones popped up for some different protocols. I could have had them all go into one topic, but just for my own simplicity, I put it into different ones so I could see what's going on. And I'm going to go into this air quality topic, and I could see what's going on here. No data is coming in now. I've got a couple of people who are supposed to be reading the data. They have subscriptions to the data. You subscribe to the data. You can share these subscriptions, or you could have them for yourself, as David was telling you. So these have been sitting here for a while with 270 records. If I know that that person's never coming back, I could unsubscribe it. I could clear that data out, whatever makes sense in your system, you know, depending on how many consumers you have and all those sort of fun stuff. But for me, I'm just going to show you, I'm going to set up some data coming in here, and we'll see it going up in the storage. What's nice with Pulsar is the storage is a separate layer. It's over here in Bookkeeper, so that's managed separately. Just wanted to show you that. So we've got no data coming in right now. I've got a Spring app over here, and this is just a standard Spring Boot app, recent version. I've got scheduling on in here. So what happens is we run the first time, we get started up here, and then after a delay, we just keep running. And I set a schema here. What's cool is I don't have to know how Avro works or JSON schemas or protobuf. I just have to set the schema right here using this class that we just have defined here in Java. And it's just fields. I gave some suggestions at what these JSON field names should be called, just to make sure that, you know, it matches everything I like, but you don't have to go to that level. So I set that. I'm going to grab my data, which is very simple code. I'm just pulling it off of a REST endpoint, get back all those observations. If it's null, something went wrong, let's just forget about this scheduled run. Otherwise, I'm going to go through all of them, you know, output some data so we can debug. I create a random key. I want to have a key so I know what's going on with my data. So I'm adding that key to the data that is sitting outside of that observation that will not mess up that JSON. I get it back a message ID when I make this call, and I can output it just to see what's going on. Now I'm doing the synchronous method. I could do asynchronous. Depends what makes sense. Since I have this scheduled, if I do async, things get a little confusing to watch. So I didn't like that. So I just turned that off. For your performance, you may want to have it async. you'll have to give that a try, see what you like. Now, to make sure the data is coming back from the system, remember I told you it goes into air quality, goes to that topic. And then I have a function running on there. Well, that's going to break it out into 3 different topics. And in Spring, it's really easy to get that data. This is all I need to do to be a listener for that. So as those events hit air quality, it'll trigger that function, just like AWS Lambda. That will produce an output, and it'll send it into one of these 3 topics, depending on what type of air quality reading it is. If it's an error, it'll go somewhere else or to a dead letter queue. But if it's valid data, it should go to one of these 3, and we'll see it come out. So I've got this built down here with Maven. I'm running this in JDK 17. You can run this on a newer one if you want. 17 seems to be a really fast one and good. At some point, I'm going to recompile this for Spring Native just to see how much faster we could get it, but it's pretty fast already. So this is, as you see here, I'll try to pause it. These are the ones getting that data back. So we've already got messages come back for Ozone in 2.5, and we could see here the message is sent. Oh, I forgot, I have a logging interceptor in there. Let's take a look at that code. That's a pretty awesome feature in Spring. So I've got one of these set up to log for the producer when messages get sent. So when a sent is acknowledged, I can get it. So here I'm just going to output some information for the field, including the schema. So I could see that the schema has made it out there. It exists in the that schema registry, makes it pretty good. So we're pushing in a lot of data to my little cluster there. If we go over here, we could see data's coming in. We could also see here the people reading it. Oh, there's a lot of producers. So it's running this in parallel. You can see here we were 200 before, we're up to 380. So data's coming in, so it's a good sign. But obviously I want an app running somewhere working with this data. It's great that Spring is pumping it out there and we display it. So I have data in those topics. Flink connects to a catalog for Pulsar. I'm going to run a little query here with some maximums on that air quality topic. As I type run there with my select, that is going to deploy it out there to my Flink cluster, and you can see the job has just started running. It is doing the source from that air quality topic. It is doing an aggregate on there. As you see, I've got those maxes and mins. And as you can see, we've already grabbed 483 records. So I'm guessing when we reload that, that's how many we'll have in that area as well. And you'll see there'll be a subscription for Flink in there. Yeah, we're already up to 500. So the amount of data is going pretty quick. It's almost faster than you can watch it. And these are aggregates. So this is the max and the min and the average, how many rows we have for that. So there's different reporting areas in the country. I picked all the major cities. And from those cities, I'm getting the different readings. So as you see here, I'll have ozone for Houston, you know, PM2.5 for Chicago, that sort of thing. Different regions related to that, and how many rows I got back as we continually run new checks. And what's nice with Flink SQL, I can go back to the start of that data in Pulsar, even if that was months ago, and as much as I want. Again, that's how you can get to the petabytes. I'm running on my laptop, so I don't have petabytes of data, but you can get a lot of data. Now, if we just wanted to look at a couple of fields, like maybe just hour observed, latitude, longitude, reporting area, that sort of thing. If I didn't spell anything wrong. Again, if you use one of those cool cloud tools, you know, you wouldn't have bad spelling errors that I have, because I don't know how to spell longitude. It's kind of sad. So we have that data coming through. You can see that old job ended already. We've got a new job. This one's a lot simpler, but what's nice is as this starts running, we'll start seeing those records. So as a new record comes in, it'll just pop in the bottom. As you see, it's going through pretty quickly. Pretty impressive actually how fast that is on a laptop. And if we look over here, we can see I'm just producing more messages. I'm going to stop the app. It's going to take a little while for it to catch up. But as you see here, now no new records here, just the ones that we had from before. Now we can look at all the old ones. If you look, we've got 27 pages of data. So we could scroll back as far as we want and, just look at all the old data as it came in before. And we'll just go to the previous pages. As you can see, a ton of data here. I could do any kind of aggregates or functions on this. Depend what's interesting to me. I could grab more fields. Pretty easy. Great way to do analytics on your data. Again, with Spring as piece of a live data stream, which makes it pretty cool that I'm doing real-time streaming. Spring is part of it. Spring could also consume downstream from Flink. If we wanted Flink to push in some of those aggregates into a new topic, maybe, or trigger something like a JMS message, or put it in a database, what have you, and then another Spring app in the mix. We've got a couple of articles on using Spring with Pulsar. The links and the scan codes are there. We added the second follow-up piece showing you how to work with the different protocols. Every week, I talk about all the cool things in open source, especially streaming. There's always stuff of Spring in there. Josh Long's articles are going to be linked in there too, and videos and all kind of cool stuff going on, different example code. I'm Tim Span. Definitely reach out to me if you have any questions. You want to see some more examples. I've got a ton of stuff in my GitHub. I'm posting all kinds of stuff more frequently than you've ever want at my Twitter, as long as Twitter's still around. Some point we'll all move to Mastodon, but for now, join me in Twitter and LinkedIn, and we'll do some cool Spring apps. Thanks for coming to my session. I hope you liked it, and I hope to see you at a future event.